Start. Good afternoon, everyone. Good afternoon. How are you doing today? Good? More fine. Quiz part of this. One question, similar with yourself. You study very well. You don't have to be worried about it. Finally, I can see you after this 1 week, just virtual 1 week. Okay, let's start today's class. Answer these two simple questions. And I'm going to start to review previous lecture. We will have a new lecture. I will solve examples. Finally, at the end of today's class, we will have quiz on game. I don't have Did you answer the questions? Who needs more time? Can you show the results? Yes. Good. Good. Let's say easy questions. Yeah, good. First question, 89%. Second question, 82%. Actually correct. Okay. We have started to talk about projectile motion. We learned about the curvilinear motion. Projectile motion is an example of the curvilinear motion. Now, for a projectile motion, for example, a football player kicks the ball. The ball moves along a curved path. This type of the motion is called a projectile motion. When, if I just separated this projectile motion along x and the y direction, or two rectilinear motion along x and the y direction. Along the x direction, the velocity along the x is constant. I show you the videos and also the example of why the velocity is constant. And also, along the y direction, the acceleration is constant. Because the projectile motion happens in the Earth, the acceleration along the y direction, it will be the magnitude. It is g, and it is downward. This type of the motion is projectile, as I mentioned. The velocity along the x is constant, and the acceleration along the y direction also is constant. For the first question, the downward acceleration of the object in a free flight motion, it's a projectile motion. The downward acceleration is always constant. This is not correct. This one is not correct. Between these two options, this one is correct. Why? This is the downward acceleration in SI units, but in US units, this number should be 32.2. For the first question, as most of you answered correctly, C is the correct one. The second one, the horizontal component of the velocity remains constant. This is the correct answer. B. These are two questions just regarding previous lecture. Okay. Now, based on the feedbacks I received from you, some of you confused about the equations. What's the projectile motion? What's the x dot, y dot? Those are I received feedbacks. First of all, this is our discussion in today ME department meeting about math, and also the requirements for ME students to just pass the math and also in other courses and relate with the prerequisite of the courses. Just simple one. X dot means that this is the variable. It's a derivative of x with respect to time. Y dot is the derivative of the y with respect to time. If x, for example, it is 4t squared plus 3 times, x dot will be derivative of x with respect to time, or it is equal to 8t plus 3. We need x dot and y dot to show the change of the variables in times. You are just studying dynamics. We are looking to find the motion of the particle or any bodies during the time. Okay? This is a static course. For static course, the body remains just at the stationary. Time is 0. You find the forces along the bodies, for example, when it's just not moving. But here, because the body moves with time, we are interested to find the time, and that's the reason we use x dot and the y dot. This questions I just confused about x dot, y dot, what those are. Just a simple one. Okay, I'm not a mathematics teacher. I'm a dynamic teacher. Hopefully, I can explain it very well. But let me know if you have any other questions. One question. Which course did you learn about the derivatives? Math? What was the names? Sorry, I do not know that. Did you know about this one in Math 102? 101? Yes? You already know this one, right? I just want to check because some of you might not pass. Or there are other math courses I found that today, math 101, 102, 203, 204, 305, 258. A lot of math courses you have. Okay. We are changing some of the math courses requirement for the NES students. You will see. Okay, then return back to my course. Okay, dynamics. You learn about week 1, session 2. Okay, we found some equations when the acceleration is constant. These are the equations. V equal velocity, initial velocity plus constant acceleration multiplied time. Why we need this equation, for example, for rectilinear motion? So particle moves with initial velocity during the time with the constant acceleration. We can find the final velocity of the particle or final velocity of the body. You know this one or from physics also too. Also, second equation, S equal S0 plus V0 t plus 1 over 2 AC t squared. I know, might be, these are the comments also I received from my previous students. We use different variables, different notations. But this equation, if you just compare with what you learn in physics, these are same, but I use different variables. Instead of S, you learn about the Y, X, for example, other type of notations. But the content and also the meaning of this one is just similar if you compare it. Then, why we need this one? For example, the particle moves along this direction. After some time from S0, we can find the position or the distance of the particle during the time if this particle has an initial value of the V0, and if we have the time, we can find the final position, final distance. Also, from this equation, we can find the relation between V and the V0 and S minus S0. For this equation, there's no time variable. Sometimes T is not given in the problem. You can use this equation, how you relate different variables. These are what I review from the week 1, session 2, and also you already learned about that. Now, for a projectile motion, bless you. For projectile motion, also you learn that it's a motion with a constant acceleration. Okay? Along the x direction, velocity is constant. When the velocity is constant, how much is the acceleration? 0. 0. Also, it's a constant. Acceleration will be 0. Now, this acceleration is constant, means that I can use these equations. Okay? Now, along the x direction means that one particle moves along x, just using these equations. For example, if I use from first equation along the x, this will be Vx, this one will be V0x. Acceleration also will be 0. Means that this term will be 0. From this equation, I can find that velocity along the x direction for a projectile motion, it is always equal to initial velocity or initial launch speed velocity, launch speed along the x direction. What does it mean? For a projectile motion, if this one is the V0, this is the launch speed or initial velocity, V0. If this one is along x, this one is along the y direction. And this angle with the horizontal direction is theta. If I ask you that how much is the initial velocity along the x, what is the velocity along the x direction? What is the velocity along the x direction? I can hear something. Yes. It's V initial cosine. It's a V initial cosine. And also V0 has a component along the y direction. What is the V0 y? Yes.
V initial times sine theta.
Correct. Now, along the x direction, from this equation, the velocity along the x, when this particle moves anytime along this path, and I just found that x component of velocity always is equal to initial velocity along the x. Means that it is always V0 cosine theta. Okay? If I just ask you that at this position, how much is the velocity along the x? Or at this position, this is the velocity direction. Then this one is the velocity component along x. This one is velocity along the component along the y. Always this, and this are equal. Or this is parallel sign. They are equal. Now, also along the x direction, if I use this equation, second one. Instead of s, I can put x. Instead of s0, is the initial coordinate x0. Instead of the v0, it is v0 x. Also, this one is 0. All of this will be 0. What I can conclude from this, it is x equal x0 plus v0 x multiplied time. This is the only equations that I need for a projectile motion along the x. Why I need this one? For example, go back to the example of the football player. The football player kicks the ball with the initial velocity of the v0. And you want to know that how much is the distance that this ball just kicks and just falls to the ground. What's the distance that hit the ground? Or if this player just used another initial velocity with different directions, how much will be kind of ball or just moves and also hit the ground further? Now, this is for the x direction. As I mentioned, we divide the projectile motion into two directions. Along the x, along the y direction. Along the x, this is the only equation you need to know. And this property, the velocity along the x, is always constant. That's it. Got it? Any questions? No? Can I move to the next slide? Yes. Oh. Now, as I mentioned, it's a projectile motion, and I divide into x and the y direction. For the y direction, or the motion along y direction, for a projectile motion, we need some equations. Along the y direction, acceleration, it is constant. This is the magnitude, and it is downward based on the coordinate system I select. Now, along the y direction, based on the equations I provided previous slide, these are the equations when the acceleration is constant. Now I want to use these equations that for the projectile motion along the y direction. For a projectile motion along the y direction, as I explained, this is the v0, initial velocity along the x is the v0x, initial velocity along the y, it is v0y, anytime. For example, when the player kicks the ball at this position, I want to know that what's the height. What is the velocity at this position? Might be somebody ask you those information. To find those ones along the y, at this position, look, this is the initial position. This is the final position. Now, you can see that at the final position, velocity has one component along the x called Vx. At this position also, it has one component along the y direction. It's the Vy. Now, I can find this velocity, this one, using this equation. Vy equal to initial velocity, v0y, plus, minus, instead of this acceleration, I put minus g multiplied time. For using this equation, if I want to find this height, I will use this equation, y equal to y0. Y0 is the initial position of this point. Usually these x0 and y0 is 0, usually. Sometimes not. You will see on the next example. Y equal to y0, instead of s0, I just put y0 plus v0 will be v0y, t minus 1 over 2 gt squared. This will be this. This will be minus g. Also, from this equation, we can relate Vy with the v0y squared minus 2g y minus y. If you do not have time, already you have the velocity at this point and initial velocity. You can find the final height at this point. Okay. Now, one question from you. If a football player kicks the ball and this is the track of the ball during the time, and the ball hits the ground. When it hits the ground, if I select this direction, X and the Y, at this point, this is the origin one. How much is X0 and Y0? How much is? How much is it? If a football player kicks the ball at the initial point, so I put the coordinate here, how much is X0 and Y0? Yes, 0. When this one hits the ground and I measure this distance as X, X will be X, but Y will be 0. Why? Because it hits the ground. This based on this coordinate, Y will be 0. This is our for the initial coordinate. These are for the final coordinate. At initial coordinate system, if this is the V0 or initial velocity, it has one component along X. It is called V0X. It has one component along the Y. It's called V0Y. Means that this one at initial velocity, it is velocity along X and velocity 0 along the Y. When this one hits the ground or the final position, this is the velocity tangent to the pass. It has one component along the X called Vx, one component along the Y, or the component of the V along the Y. At final position, it has one component Vx, one component along Vy. That this Vx is equal to V0x. If you know those components, putting into these equations, you can find the velocity or the height anytime. Okay, now solve examples. Okay, move to the next slide. This slide just what I put it here for you. If you want to solve homework 3, just put this slide in front of you. These are the equations you need along X and along the Y direction. And this is the summary of the projectile motion. Okay, I just want to help you. This is the procedure for the analysis. And if you want to review previous lecture, this slide helps. I captured from book. Now, first example. The example that I showed you in the previous lecture, I will put the recording how to solve. Just because we don't have much time, and also I want to solve more examples. I put the recording of that example that you have to watch. And also today I want to solve more examples. Okay. Now, this example. It's a catapult. It's used to launch the ball such that it strikes the wall of the building at the maximum height. This edge is the maximum height. And it takes 1.5 seconds to reach from A to the B point. We want to find the VA, take up the angle of release, and also the height when hit the wall. This is a type of projectile motion. Okay. It's a projectile motion. Now for this projectile motion, first step, important step, to select a coordinate system. Where do you want to put the coordinate system? For example, some of you are interested to put the coordinate system on A point. Some of you are interested to put the point here. It's optional. It's not mandatory to select the coordinate as I'm selecting for this problem. For example, you will see this point. I put the coordinate system here. We need a coordinate system for each problem along the x, along the y direction. Now for this problem, just I will write whatever I can see or I can understand from this problem that help me just input into equations. Now for this problem, I have to select initial point and final point. The initial point for this one is A. When the motion started, okay? For this motion, when A is started, how much is x0 and how much is the y0? How much is x0? 0. How much is y0? 3.5. Now, some of you might be interested to select this blue coordinate system. I am interested to just put the coordinate system, not the red one, the blue one, starting from the kind of strike or initial point. Based on this coordinate system, how much is x0? How much is y0? 0. Based on the blue one, is 0. This is the reason when you selected this coordinate system, you have to be careful. Then, for the final point, just when hit the ground, hit the wall, this is the final point, or final, just when the water hits the wall, B. Based on this, based on the red coordinate system, how much is x? 18. How much is y? H. Sorry, just the pixels on my notepad just doesn't work. But I want to show you also, if you selected the blue coordinate system, how much is x? How much is x? 18. How much is y? H minus 3.5. Okay? This is the reason, just mentioned that. If you just put those ones based on the coordinate system, you have to be careful about the ones. For example, for the blue one, you cannot put the red one. Just I delete, not to confuse you. Just there's not only one solution for the problems. Based on the red coordinate system. Now, also, I need to just write at the A initial point, what is the velocity along the x, what is the velocity along the y, and also at the final point or final destination, what is the velocity along the x, what is the velocity along the y direction. Now, how much is the v0x at A? Here. How much? Sorry, I cannot hear. I need to just I think that I have to check my ears. I need some hearing aids. Just say louder. How much is the V0x? Yes. 18? No. 18 is the distance. Yes. Yeah, you mentioned.
No, I thought I said cosine of VA.
Correct. Cosine VA. At this position, this one is the VA. Cosine theta, or this is VA, cosine theta. Along the y direction, this component, it is VA sine theta. When the water hits the wall, how much is what is the Vx? 0? What is the Vx? Yes. V initialized. For the projectile motion, the velocity is always along x is constant. Vx is V initial x, or it is VA cosine theta. Now, at the point B, there's the maximum height. What is the velocity along the y direction? Do you agree? Is it 0? Do you agree, everybody? It's 0. At maximum height, this is the velocity. Emission that's maximum height. Means that the velocity at this point has only component along the x. There is no component along the y. This will be 0. Okay? If you write this one, in my opinion, you just solve the 50% of the problem. Later, you have to just put in the equations and solve the equations. Now, you know this, and also t, it takes 1.5 seconds. From A to B, it takes 1.5 seconds. These are given for this problem. What I'm looking for to find, I'm looking for to find VA theta h. I have 3 unknowns. How many equations do I need to solve 3 unknowns? I already answered the question. We need 3 equations. To find 3 unknowns, you need 3 equations. Okay? Next step to solve the projectile motion. Okay, move to the next slide. Okay. Now, as I mentioned, I divide the problem into motion along x direction. Along the x direction, there is only one equation, x equal to x0 plus v0x multiplied by t. I make those ones here, just small one, for your reference. Now, using this equation, we have the x. Look, I just put those ones that I have. x0 is 0 plus v0x, it is va cosine theta. This is this. And t, it is 1.5. This is equation number 1. Along the x direction, this is the only equation that we can find. That's it. Let it go. Then move to the y direction. Motion along y direction. Motion about the y direction. I just go here. I bring the, oh no. I just want to exactly put the equations that you already have it and just use them to show where I use those equations. These are the equations already I will give you for exam. That's it. Now from these equations, I need 2 more equations. I need to select 2 equations from this out of 3 equations. For example, first select the first one. Okay. Vy, I have the Vy from this equation. 0. V0y, I have it Va sine theta plus acceleration is constant. It is minus g multiplied by time. Or if I rewrite this equation, Vi sine theta minus, how much is g? 9.81. Do you agree? How much is? Yeah. I'm not looking for the number. I just want to know that you do not just confuse the G from SI with the US units. This is a very common mistake. You will see that I use this unit and US unit in this problem. You cannot use G 9.81. If you do this one, I already accept the solution if you just can submit it. But finally, you cannot find these values correctly. You will miss at least 3 points in here out of 20 points. 1 point also will be decreased from you because you do not select the G as a correct answer. You will lose 4 points at least by very small mistake. Okay? Now, using this minus 32.2 and t is 1.5. This is equation number 2. Now I need one more. I select this equation. Y height at this point, it is h. Y0, it is 3.5 plus V0y, it is Va sine theta multiplied by time plus 1/2 AC t squared. I rewrite this one again, h equal 3.5 plus Va sine theta multiplied by 1.5 minus 1/2. This is g, t is for 1.5 squared. This is equation number 3. I highlight the equations. This equation, this. Now I have 3 equations. I need to solve 3 unknowns. You are expert in mathematics. Let me know how can I solve these 3 equations to find 3 unknowns. Yes?
Do substitution. Take the second equation.
Okay? Okay? Now, correct. For example, from this equation, I can find the VA, then plug in this one into this equation, then I have one unknown, is theta, I can find. Is if you do this one, from this equation, let me change the color. From this equation, I can find that VA, it is 32.2 multiplied 1.5 divided by sine theta. Just bring 32.2 to the right and divide by sine theta. This is the VA. Then, if I plug in this one into this equation, I will plug in VA into this equation. If you plug in here, it's the H18 equal to VA. It is 32.2 multiplied by 1.5 divided by sine theta multiplied by cosine theta multiplied by 1.5. Just as a simple calculation. And this is the reason you have to bring your own calculator. You cannot find the theta using your hand. Okay? If you can't find it, let me know. If you find from this one, I want to cheat. I already solved from my first class. Theta will be 76 degrees. If you do not believe, you can calculate. Okay? Theta is 76 degrees. Also now, I have the theta, I can find the VA. How? Just plugging into this equation. 32.2 multiplied by 1.5 divided by sine 76. I can find the VA. I just write in here. VA will be, there's my phone. Okay, here. VA will be 49.6 foot per second, or 49.6 foot per second. Then, if I use equation number 3, from equation number 3, I can find H. H will be 3.5 plus VA, it is 49.6 sine of 76 multiplied by 1.5. Continue. Minus 1 over 2, 32.2, 1.5 squared. We calculate it. It's good that you have the answer. Is 39.7 foot. Another answer. This is the answer. This is the answer. This is the answer. Got it? If you just saw and also follow what I saw, you will see that from the second slide, just I bring the equations, just substitute into the equations, and the remaining is just calculation. Dynamic is easy. My any questions? No? Good. Did you find another number? Okay, move to the next slide. Yes, everybody. Now, second example. A football player just kick the ball at the point A with the initial velocity of 10 meters per second. The launch angle is 30 degrees. The ball hits the ground at point C. We want to find that what's the horizontal distance it travels, and also what is the magnitude of the velocity at C. Let's solve this problem. For this problem, this is a type of projectile motion. What is given to us? Initial velocity is given. I just put this one V0, 10 meters per second. A is the launch point or initial point. Based on the coordinate system is given here, we want to find x0 and the y0. And also, when this one hits the ground at C, when it hits the ground, we want to know what's the x and what is the y. And also, at A position, what is the V0x? What is the V0y? At C, what is the Vx and what is the Vy? Now, ask some questions. How much is x0 and y0? 0. 0. This is the initial point. The coordinate already is given to you for the problem. X0 and Y0, they are 0. That's the easy one. How much is the V0x? 10 cosine theta or 10 cosine 30 degree. How much is V0y? 10 sine 30. That's correct. Just whatever I ask you, just put in here. 0, 0, 10 cosine 30, 10 sine 30. Now, at point C, when it hits the ground, x, we do not have. We need to find this. This is x. How much is y? 0. At C point, how much is Vx? 10 cosine 30. It's 10 cosine 30. Why this one is this? Because this one is equal to initial velocity along x direction. We are looking to find this one. But we can't find this one. Is there anybody that can guess how much is the Vy? Yes.
10 sine 30.
Why?
Because it's the same as the V initial Y.
You guessed correct. And also answered correctly. And also we can answer this one using the equations. I will just answer it. But let this one as an unknown. Now, these are the given one. What I'm looking for, I am looking for to find x and the velocity at the c. Velocity at the c, it will be the magnitude of Vx squared plus Vy squared. I'm looking for these two. Got it? Let's move to the next slide. I know some of you might be interested to just, I finished in the solution in one slide, but it's much better just not to just bring all of these in one slide, become easier. I just copy the first slide and the kind of corner that you can see I use those numbers. Again, I just divide this problem along x direction. For the x direction, there's only one equation, x equal x0 plus v0 x t. You will see x, we do not have, x0 is 0, v0x is 10 cosine 30, then multiply by time. Also, we do not have time. How much does it take to just reach the ground or hit the ground? We do not have. Then, this is the only equation we have for x direction. For the y direction, I want to select the second equation. Just I will write it this one. Y equal to y0 plus v0y t minus 1 over 2 gt squared. The reason I select this equation is because we have the y, we have the y0, we have the v0y, we have the g. The only unknown in this problem is t, time. I can find time from this equation, plug it into this equation, find the x. You have to be smart to select this equation. Why? If you select the first equation, you do not have this, you do not have this. Also, third equation, also there is no time for the third equation. Erase. Now, from this equation, y is 0, y0 is 0, plus V0y is 10 sine 30 multiplied by time minus 1 over 2. G is 9.81. T squared. This is a polynomial equation. If you solve this problem, this equation, from this equation you can find 2 times. The first one is 0. It's obvious. The second one, if you solve it, just to solve this one, you can take time. It's 10 sine 30 minus 1 over 2g, or 9.81 t equal to 0. This is from this equation. If these two expressions are 0, means that t is 0 or this one is 0. Now, from this, if you solve, you can find the second time. It's 1.019 seconds. This is the time that shows how long does it take that kind of ball reaches to the ground or hits the ground. Now we have time. We can find x. If I plug in here, is 10 sine 30. Just plugging time into this equation. Or multiply 1.019. If you calculate this one, let me see. X will be 8.83 meter. This is one answer I'm looking for, the horizontal distance. Then we have time. For the y direction, I will select second equation, the third equation. Vy equal to V0y minus g multiplied time. From this equation, we do not have the Vy. We have the V0y, 10 sine 30 minus g is 9.81. Time also, it is 1.019. If I calculate this one, it is approximately 5 meters per second. Also, we can find the Vy from the V0y. From another equations, if you remember, Vy squared equal to V0y squared minus 2gy minus y0. Also, if you use this equation too, look, because y and y0, they are in same just coordinates. This will be 0. From this one, we can find that Vy, it is equal to V0y, the magnitude. The direction is downward. This is the reason I asked you that. Do you know that how much is the velocity along the y direction when it hits the ground? Now, we have the Vy, means that when this ball hits the ground, this is the VC. Velocity along the X, it is 10 cosine 30. Along the Y, it is 5. I just found it. Then velocity, or the magnitude of this one, it is 10 cosine 30 squared plus 5 squared. If you just calculated this one, you will find that this one is approximately, just delete this, 10 meters per second. Any questions? Yes. Yeah. Hey guys, any questions? Let's have 5 minutes break. I know. I will keep the break. It is. Oh my God. I'll send it to him, but I finished. Can you divide it by literally? Yeah. I like the so if you start with yes, it is. Yeah, I did this. But I went back. I also did that. Yeah. I already found it. I just reversed what oh, I did it here, yeah. What's the same? One shot. Can you check that?
I'll try like wires. Yeah, I was like, how do you do this?
Or just code the juice, or I'm not sure. Yeah. You just write this one.
It also oh, it's like the same one.
Find this one.
But I would.
Who is this for the first one? You can find it. You know what?
So on the screen, it says one rebooted, one. So there's an arrow.
Yeah.
How that's what it
So I found out that he had one homework about 3 years ago. Oh, teachers. Love it. Two I'm sorry, I'm gonna sit here. It's also okay. Yes. Yeah, they close early. Yeah.
I've set up the where
That was ridiculous.
I know.
And I teach this. Yeah, all of the every
Yeah.
Don't worry, it's like everything. It goes amazing.
So bad. We were all over the place. I'm having so much fun. I'm not, it's just how.
Hey guys, let's resume the second part of the class. Any question from first part? No? No questions? Okay. What I'm going to do, just I will teach until 3:05. Then I will start the quiz. Make sure that I do not pass 3:05. I like teaching you, just continue, and then I can see that, oh, there's no quiz one. I do not like it. Okay? This part of the lecture is about the same curvilinear motion, but in different coordinate systems. The coordinate system that's selected for the first one is the X, Y, Z coordinate system. And we found velocity and the acceleration along X, Y, and Z direction. Now, we want to select another coordinate system. This coordinate is new for all of you. Why we need to select this coordinate system? Based on the problems you will see here, we will select this coordinate system because it's more convenient for a curvilinear motion. You will see why when I just introduce this coordinate system. And exactly what I did it for the curvilinear motion and X, Y, Z coordinate. I found velocity and acceleration. Just review, quick review. For a curvilinear motion along the X, Y, and Z direction, for example, it's a coordinate look like this, X, this is Y, and this is Z. Or any type of coordinate. Just some of you will mention this is like X, this is Y, anything, just this coordinate. Along this coordinate, if the particle or body moves along curve, anytime I can find the X value and the Y value of this one, and also the Z value of this particle, that it will change during the time. Now, we can find their velocity. Velocity along the X, it is X dot or derivative of the X with respect to time. Because X will be changed with time, the velocity along X is X. And also, we can find the velocity along the Y. It's a Y dot. Velocity along the Z, it is Z dots. These are the velocities. And also, we found the acceleration along the X is X double dot, or the second derivative of the X with respect to time squared. The acceleration along the Y is the Y double dot. Acceleration along the Z, it is Z double dots. This is what you learn. X, Y, Z is given to you, will be given to you by finding the derivative or second derivatives. We can find the velocity and the acceleration of this point, for example, this tag point, based on this coordinate system, X, Y, and coordinate system. However, sometimes it's more convenient. I will show you why. To select normal and tangential coordinate. And we will find the velocity. For today, I think that I can find the velocity only, and the acceleration will be for the next session. Now, what are the applications? These are two applications, just I selected from, related to the mechanics or mechanical engineering. There's a camshaft drive system of 4-cylinder automobile engine. For this system, you will see there's belt and some of the kind of gears. And here, if this velocity is given to you, the velocity of this timing belt, you can relate this velocity with the radius of the gear at this point. Or find the velocity at the point P2. Or what is the acceleration of the P1 or P2 if this velocity is given. And how you can select this kind of gear radius. Or for this timing mechanism, this peg point is just moving along this slot. And we can find the velocity of this point anytime along this slot, or the acceleration. How you can design this mechanism? Based on the, for example, you know the velocity and the acceleration, or this velocity is given to you. I will show you. To know those ones, I want to introduce the normal and tangential coordinate system. What are they? How we can draw them? What are their directions? And how they move with a particle or bodies. Look, this is a sinusoidal curve. I like always for a curvilinear motion. Now, if a particle moves and just move on this curve, it has a curvilinear motion at different points. Here, 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 for example, I want to show you how we can draw the tangential axis and normal axis. For example, at this point, top point, if I draw a line that is tangent to this line, or tangent to this curve, this line is tangent to the curve at the top point. Now, and also, this particle moves from left to the right, for example. The tangential axis or tangential coordinate will be along the tangential line. And the direction of this one, it is parallel or it is along the direction of the motion. This axis is called tangential coordinate system. Also, the normal coordinate, it is perpendicular to the tangential axis. Now, we know the directions, but which direction? Just based on this line, it can be this direction or this direction. Which direction is the positive direction of normal axis? The positive direction of the normal axis, if this is a curve, a general curve, one point is called center of the curvature. Okay? This point is on the concave side of the curve. Then, normal axis is if this is the point, this is the center of the curvature. For example, for this portion of the curve, the normal axis will be along this line, and it is positive toward to the center of the curvature. Also, for another point, for example, for this point, tangent axis or tangential axis is tangent to the path. It is parallel, same direction of this point. Okay, the tangent t-axis is tangent to the path and it's positive in the direction of the motion. The normal axis is perpendicular, this, if I draw a perpendicular line, and it is positive toward to the center of the curvature, this will be the normal axis. Or at this point, this is the tangential axis. And if this is the center of the curvature, for this part of the curve, normal axis will be in this direction. If I ask you to compare the XY coordinate system with the normal and tangential coordinate system, how do you compare them? What are their differences? What are the differences of the XY coordinate system and normal and tangential coordinate system? Let me help you. If you compare with the previous content I just tell you about the curvilinear motion XYZ coordinate system, what are their differences? Let me have one of I tell you one of the differences. One difference is this coordinate system is fixed. But this coordinate system, it moves with the body. If you just remember the car moving along past, just we put one coordinate, just based on the coordinate we found the location. However, based on this coordinate is just attached to the body and it moves along the curve. What does it mean? It means that you will see the tangential axis at this point is toward the right, at this point is this direction, at this point it is in this direction. Their axes will be changed during the time. And it depends to the position. As I mentioned, for example, for normal, it just shifts from one side to another one if the curvature changed. Also, as I just introduced this coordinate is more direct and convenient because it moves with the body. I do not need to convert it. For example, if I just put XY coordinate system here at this position, it will be here. At this position, it will be here. At this position, it will be here. Or the body wants to rotate, I need to just rotate the XY coordinate system and use the translation of the axis. Okay, now, one simple question, just to show you the direction, correct direction of the particle. For example, the particle moves from the point A, goes to the point B, and also C, and also D. This direction, clockwise direction. At each point, for example, right, if I just put 1, left 2, up 3, down 4. Now, at position A, what is the correct direction of tangential axis? Based on this sign numbers or coordinate numbers. 1, correct. What is the correct direction for normal axis at point A? How much? Which number you select? For normal axis. 4. It's downward. How about the point B? What is the correct direction of T? Correct direction of T. Just I check it. It's 4. What is the correct direction for the normal axis? 2. You will see that from this simple example, this is T normal, sorry. T normal, T normal, T normal axis. T normal. For a car that just drives and also moves along a circular path, you will see that how tangential axis will be changed. Sometimes it's along 1, 2, 3, 4, and also the normal axis. Also, you will see that they are in different directions. But for the normal axis, you will see that they are all toward to the center of the curvature. Center of the circle also is the center of the curvature for a circle. Okay. Now, some of the fundamentals for the normal and tangential coordinates. Same as that we had the unit vectors along x and the y. Also, we have unit vectors for the tangential and normal. There's a center of the curvature. These are the center of the curvature. And also, there's the radius of the curvature. Rho is the radius of the curvature. If you just draw a kind of line from O and that is perpendicular to this line at this point, this will be, if you measure this distance, is rho. And also, S is the distance. Along the curve that moves, we measure S. Just with increasing and moving along this curve, S will be increased. And we can find the arc length. This is from mathematics. If you have the angle, you have the radius, you can find the arc length, that is ds, is equal to rho d beta. This is what you need to know for this coordinate. That's it. Then, I want to find the velocity in this coordinate system. To find the velocity for this one, at this point, you know the velocity is tangent to the path. Then, already just, if you watch the video I posted for you, I show you the velocity is tangent to the path for any type of motion. It's a rectilinear, it's a curvilinear, any type of motion that you know, velocity is tangent. The direction will not be changed. Based on the coordinate system I introduced to you today, this will be tangential, and this will be the normal axis. You will see that this velocity, it is along a tangential axis. Velocity doesn't have any other components along the normal. Based on this coordinate system, because velocity is tangent, it is parallel to the t, means that velocity is equal to magnitude of velocity, and ut is the unit vector along the t. This one shows the velocity vector in this coordinate system. We know the direction and the velocity, the magnitude of velocity or speed can be found using s dot. If you remember in the previous slide, I just explained that along the curve from one origin, we can find the position or distance using s along the curve. If we measure the change of s with respect to time, this will be the speed. or the magnitude of velocity. As if, again, this one moves along this curve will be increased, means that the velocity will be increased with this S. This is the velocity. This is the easiest. Any questions? No? Okay. Now I want to find the acceleration. How can I find the acceleration? How can I find the acceleration from velocity? How? Which formula should I use to find and relate acceleration with the velocity change? Yes? Correct. Acceleration is the derivative of velocity with respect to time. Okay? Easy. I need to substitute this one into this equation and take the derivative. It looks easy, but do not panic. This is the reason I prepared you. This is how we can find the acceleration. I just plug in the derivative of velocity into this. These are some of the ones. I just put this slide for some of you who are crazy in mathematics or crazy to just find the equations. But please, I have this one for you to follow. But I do not want to explain. Based on my experiences from my previous classes, 1 out of 20 students are interested to this slide. But this slide for that student, or 2 students, or 3 students. I want to show you the final formula. Okay, this is for your reference. To find the acceleration in this coordinate system, the acceleration will be this vector. Acceleration has 2 components. One along tangential, one along normal. Along the tangential direction, they will be v dots, or the derivative of velocity with respect to time. Along the normal direction is this. It is v squared divided by radius of the curvature. Okay? To prove those ones, return back to the previous slide. Okay? Why I got those equations and this. Again, along tangential, it is v dots, or change the velocity with respect to time. Along the normal, it is v squared divided by rho. This acceleration is because of the change here, emission here. Because the change in the direction of the velocity change, this acceleration is because of the change in the magnitude of velocity. Or exactly these are coming from. If it's a car moving along a curved path or along a circular path, at this point, this car has an acceleration of at and has an acceleration of normal. This acceleration can be found by changing the magnitude of velocity. This acceleration can be found by square root of velocity divided by rho, or radius of the curvature. This is the reason. If you're just driving, when you want to change the direction, for example, go from I-75 to I-69 or those ones, there's a ramp. Have you ever just, when you try to just move, you will feel some forces just move you towards this curve, not along the direction of you driving. This is because of this. You have velocity, and also those ramps. For example, look, this, when you just want to just turn and move to this direction. When your car is in here, you have velocity. That's the velocity. This is the acceleration you have. Already, you have this one also too. If you increase your velocity, you will increase this force. Okay? And my pain. Unfortunately, and you have an accident because this one can increase this acceleration and also this one too. One simple question. If I move along a kind of a straight path, okay? Move along a straight path. Do we have this acceleration? If you are just moving along a kind of straight path, do we have a normal acceleration? It's a conceptual question. When you are driving, there is one acceleration in the direction of driving. Is there any another acceleration in this one? Just neglect those ones. No. Why? Because based on this one, on the straight path, radius of the curvature is infinite. Radius of the curvature is infinite. This is the reason. This one, it will be negligible. Got it? Do not try when you are driving, please. This is for class. Any questions? No? Let me give you one more slide and then start quiz. Homework 3 uploaded today. And also you have just until tonight to upload your homework 2. Okay? Please upload it before the deadline. Okay? Good? And I will post the homework 2 solution for you. And homework 3, I will upload. This is regarding projectile motion. I want to start a quiz. If you can distribute in the classes, or some of you just sitting at the round tables. For the quiz, you can use your notes. Okay? Do not use your neighbor's note. I will check. This is my responsibility. For the quiz, you have time until the end of class, 3:25. Okay, there's one question. I will distribute those papers. Write this one here, and when you write it, this paper is for you. But I need you to scan it, upload it in the Blackboard. Okay? I do not need this one. That's for you. And make sure you completely upload in the Blackboard. When you just leave the classroom, and also I will try, and this will be disappeared from the Blackboard. If you haven't uploaded or incomplete submission, we'll get 0. Got it? It's a simple question. start. Yes. Finally, we have quick one. And half. Yes. No. Our 30 students. You have one more. It's easy. Oh. Please write it completely. Any formula needed, just write it. Make sure you calculate correctly.